I am representing the FP Insurance Group to present its argument in the pump station fire case. Texas Builders Construction was hired by the Water Management Department to renovate the storage room in the basement of the pump station building, as you see in this plan. While welders were working inside the room, which is here on the left side of the plan, they caused a fire resulting in damages to the room and its contents. These two columns, which are shown using the red dashed line circles, were also buckled as a direct result from the fire. In this picture, you can see what happened to the columns caused by the fire incident inside the storage room. But unfortunately, damages in the pump station building were not limited to just the mentioned damages inside the storage room. After the incident, the operating manager noticed this pipe, as you can see in this picture, and also this pump shaft on the ground floor, as you see here, were also broken. To realize the failure mechanism and the causal relationship between the fire inside the storage room and the damages to the equipment in the other parts of the building, we have to run the post-incident structural analysis using the finite element analysis software. Before moving to the analysis result, I need to explain the structural system of the building because it is very important in understanding the analysis. As you see here in this section, the pump station is a 2-story building, including the basement and the ground floor. This building has steel beams and steel columns with concrete roofs and floors. Also, the pump station building has individual footings under the columns and strip footings under the walls. To investigate the causes of the pump shaft failure, we have compared the deflection modes before and after the incident that we got from the finite element model. This is the deflection of the beams under the damaged pump, as you can see here. But before the incident, we have small and negligible deflections in the beams, in particular under the pump shaft. But when these two columns buckled under this new condition, we have a significant unbalanced deflection in this beam, which is 2 inches according to the analysis result. Now, let's take a look at the specifications regarding the allowable deflections under the pump to see how large this deflection would affect the pump shaft. Here, we have the pump manufacturer's catalog. According to this catalog, the maximum allowable deflection on the shaft is 0.25 inches, which is smaller than the unbalanced deflection caused by the buckling of these two columns. So, we can deduct that our post-incident analysis proved that the pump shaft break on the ground floor is the result of the fire in the storage room. This was caused by the unbalanced deflection under the pump exceeding its designed tolerance. Another damaged area resulting from the fire occurred outside the storage area. In addition to the pump shaft breaking on the ground floor, as you see here, was the damage of this pipe located in the pipe room next to the basement of the storage room. As you can see here, this pipe was tied to this column, so we thought, and therefore this damage may have been caused by the settlement of the footing underneath this column. To investigate the failing mechanism, we analyzed the changes of the footing loads in the building after the fire when these two columns buckled and did not perform in bearing the loads from the building. Footing loads are the portion of the building loads which are transmitted into the soil from the connected structure through the footing. To analyze the footing loads, we use the finite element analysis software as we did for the building deflection mode. In this slide, you have seen the analysis result before the incident. Under this condition, column A and column B have higher loads in the building. Under column A, we have 210.7 kilo-pounds of force, and under column B, we have 163.9 kilopounds of force as the footing loads. If we divide these values by the dimension of the footing, which are the same for all individual footings, we get 4,300 pounds per square foot under column A and 3,345 pounds per square foot under column B, as the pressure on the soil both less than 4,500 pounds per square foot, which is the allowable pressure on this specific soil according to the geotechnical report for this location. According to this analysis, we can deduct that the settlement of the footing from this building and before the fire incident was very unlikely. When these two columns buckled as a direct result from the fire incident, according to the analysis result, we get 5,600 pounds per square foot as the pressure on the soil under column A and 4,551 pounds per square foot as the pressure on the soil under column B, both higher than 4,500 pounds per square foot, which is the recommended soil bearing pressure according to our geotechnical report. When the footing load becomes higher than the allowable soil bearing pressure, as this happened in this case, consequently, we expect footing settlement under columns A and B, leading to the pipe breakage in the pipe room, which was leaned to the column B. Overall, according to our investigation in which I demonstrated, the plaintiff, FP Insurance Group, believes that the defendant, Texas Builders Construction, is liable for all damages inside and outside the storage room, including the buckling of these two columns. Inside the room, the pipe breakage in the pipe room next to the storage room, and the pump shaft breakage in the pump room on the ground floor, and have to compensate all of these damages. The Texas Builders Construction declined its responsibility for damages outside the storage room, claiming that the accessibility issue of the building to the storage room slowed down the firefighting process, and the existence of the flammable materials added to the intensity of the fire, which were out of the contractor's control. This defendant also claims that if the columns resisted the fire according to the standard, the damages outside the storage would have not occurred. However, this claim is not acceptable because of our contractual agreement succinctly stating that the contractor is liable for all damages to the building during the work, with no exception. Thank you for your time and attention to this presentation.